Hello, hello. Um, Hello, guys, and welcome back once again. So, the idea is a little bit different from what I've been doing. So, today we're just going to do some brief discussion about data science, some of the things that I've actually learned when it comes to building machine learning models, AI systems, name them, agentic systems, and so on. So, I got this nice idea, this nice topic concerning machine learning. Again, why do so many promising projects stop after the notebook file? Okay, so let's do a deep dive into this and see why this they tend to fail. So let's say now. So my point one about this is that when you build a model, then from ideation, build a model, then from ideation, let's say in my Jupyter notebook and up to that point. Okay, so it does not mean that that marks the end of it, but that's only the beginning. So in most cases, people tend to begin that, and you evaluate the model, find that the accuracy is good, then that's the end of it. So that's not really what happens when we are building these ML systems. And this also cuts across if you're also building, let's say, agentic systems, the RAG agents, um, graph RAG agents. So it does not only stop with the notebook file, but there's still a frontier to be conquered when after you have evaluated your models. And so in reality, the sequence tends to be a little bit different. So you start with a business problem. What problem are you trying to solve with the model you're trying to build? So this is the some sort of a chit chat you'll be having with the managers, with the supervisors, or your clients for that matter. So you need to understand what is the business problem that you're trying to solve. Then from the business problem, you move on to the next step about data. So from the business problem, now what data do they have that we can leverage to actually solve their business problem? Okay, because in machine learning, if you're building ML systems or generally in the AI field, we data has to be the underlying asset for that matter. If you don't have data, then we don't have AI systems. So data is the oil that AI systems are built on top of that. So once you understand the problem, you move to the data where you take a brief look about the data that you have. What are you missing information? What information are you missing from the data that based on what they need solved, it cannot be solved because you're missing that when it comes to when you're looking into the data. So you have to take the business problem that you're solving, the objectives, then compare that with the data that you're having. Is the data matching? Or if that data does not match, then we need to readjust the goals that we have. So based on this data, then we need to tweak objective 2 and 3 so that we're able to meet the data requirements. Or yeah, I think that's the goal if you are proceeding with the plan. Then once you have the objectives that you're trying to solve, so that's the business problem, the business pain, then you've seen that the data can be used to solve that particular problem. The next point will be now moving to your notebook file. So that is where you develop the models itself. So with the models, again, as I usually say, that's more of research. It's deeply into research, more of research, because depending on whatever tools you're using, I prefer using a notebook, Jupyter notebook files. So the notebook, you're able to ingest the data, do exploratory data analysis, famously called the EDA analysis. Then once you have your analysis in place, the analysis will give you a sneak preview about the data itself, or characteristics, different patterns that are existing within that data. So that's all about the model development. So once you develop the model, then you have to do the deployment, because a model within your Jupyter notebook file is not really something that drives value. Book file, then it becomes a useless model, even if you've come up with the most accurate model based on the data that you're using. Okay. So once we deploy that model, it's now at the end users. The end users can interact with that model, and that's how we drive that value. So we've solved that problem, and we have deployed our model. It's now accessible to the end users. They can interact with the model, and it can help them solve problems or challenges. Then after that, then that's the use case. Then we do the monitoring, maintenance, and governance in production. So building a model inside a notebook file, that's I cannot say even it's half of the entire process, but that's also a tiny bit of the entire process. And most projects tend to fail at that stage because, I don't know, maybe they don't have the expertise to move a project from a Jupyter notebook or a test environment into a production environment, or it can be any other. But again, failure to reach to production, that can be one of the reason. Building a model isn't just the end-all process. The end-all process is getting the model from your test environment to a production environment, and setting up the monitoring and maintenance and all governing tools or principles that are able to govern that model, ensuring that our predictions should be as we expect. So deploying that and ensuring that data drift, concept drift, things like that we're able to govern that model in production. So that's what we should aim for. Okay. So generally, or a parting shot under this is that a model only creates value if the people can actually use it and can actually see the value itself. So a model in a notebook file cannot generate that value, or then a deployed model, that means deployed model either to cloud or on-prem servers, then the end users can use it. Then that's how ML systems can actually help us solve these challenges. Okay, and that's how we create value now when we are building these models. So building a model isn't the finish line. So that's a reason as to why some of these projects don't get to production. Point number 2 can be a challenge that also I was facing, especially when I was beginning with ML systems, and that is the real problems it's not really the algorithms, but the underlying asset. So I usually tend to call it underlying asset, meaning the data itself. So the real problems aren't the algorithms, but the data itself. So what type of data are you working with when you are building this system? So that's also something that we need to consider when you are working with this, when you're building these ML systems and so on. So if you a form that can be ingested by the algorithms for that matter, then definitely we are going to have challenges in terms of the predictions that we will be making. And so messy data is a challenge that will affect the quality of the models that you're going to build. And so most failures tend to happen because of the messy data, changing data. That means you haven't organized that data into a form that can be ingested by the models. Also unclear business goals. If you're building models without clear business objectives, that's also a challenge that will bog you down, and it will derail the process of deploying these models. And so another problem is about the deployment plan. So what is the deployment plan of this model we are building? Again, we have seen a real example, a real case that a model in a Jupyter Notebook file, or a Jupyter Notebook, I'll call that a test environment. So a model in a test environment is not really productive. It will not generate the massive gains that you need. So you need to have a plan to take the model from a test environment to a production environment. So if there's no development plan, I don't think to start with that is a worthy project to even build. Okay, so you need also to consider that. And also another thing that goes hand in hand with that is about maintaining the model. You need at the onset, when you have decided to build an ML systems or any AI systems within organizations and so on, you need to actually have a system set up in place about maintaining those models. So I usually call ML systems as a type of dogma that you need to understand the rules well before you even attempt to build such a system. Okay, so dogma meaning that once you get in and you understand the rules of the game, and you have leveraged AI systems to drive value, it might be hard for you to get out of that process if you did set it up right and ticked all the boxes when it comes to building such systems. It might be hard for you to get out because you already realized the value of that. And so if you have done that well, then you need to understand the other half of the bit. Okay, and that is all about how are you going to maintain the models, and how are you going to maintain those models in production. So if there's nobody maintaining that model, then that value curve will soon diminish, get to zero, because as we say during when building ML systems or AI systems, is that data tends to change. The environment changes, okay? And if your models that you're using are not receptive to this change, or they are not allowed to recognize these changes, then you tend to use your past victories in the current domain, and that is a reason for you, or a reason that you will tend to make a lot of mistakes. So if there's no that maintaining systems put in place, then you actually there will be challenges arising, and you have to move ahead of the curve and ensure that model governance, model maintenance are all things that you consider before joining or before setting up projects in machine learning. Okay, so so I think that's another point. Okay, so the third one about why most data science projects never get to production. So the third one is about I think this one is one of the reasons that I've also fallen. Business should come first. So I think this one is this is also something that has been also a challenge, especially if when I was starting the ML journey or the AI in the AI domain. So businesses should come first. It doesn't matter which type of model you are building. It doesn't matter how good that model will be. But if you're not solving a business problem, then it is as well as to just quit with that. Unless it's a hobby project, we can vouch for that maybe. But for building systems in production systems, then I do believe that the business goal should come first. And when I'm saying the business should come first, because they're the ones paying. Okay, so if you're not solving their problems, then it doesn't matter how cool or your model is, or how fast or how accurate your model is in giving predictions. Okay, it doesn't matter if it does not solve the real problem that we either tried to solve, or so it doesn't matter. So you have to be upbeat from the get-go. You need to be clear with what business goal you're trying to solve. Otherwise, you'll build those models, you'll deploy those models only to realize that we are not solving the problems that we were supposed to solve. And so that can be a problem or a challenge that data science teams need to consider or need to focus on when building these ML systems. So examples of problems most of us we can encounter is how can build models to reduce waste. For example, in a retail sector where the margins are too thin, so the upside is they need to focus on volume so that they can cover for the losses and so on. So we can build a model to reduce waste. and you need to know that at the onset of that project. For banking, finance, we have models like detecting fraud and so on, credit risk and so on. So you need to be clear how on your approach on how you're going to solve that problem. Okay, prediction, demand prediction, time series models, churn reduction, and so on. So when you're building these models, you have to be sure on the type of or the objective that you're trying to solve. Otherwise, if nobody knows why the model exists, then it surely dies. Then there's no value that we are going to get from that model. So we need to be upbeat and realize that we are solving this model, and the target that we are solving is X, and it should be clearly defined. It should not be and or situations. So it has to be clearly defined, and then because the output will now be used in making decisions and so on. So you have to be aware of that. Then another problem is about production, especially when you are deploying these models. So production is also an engineering problem we need to consider. So test environments are easy to set up. You can set up a test environment without breaking an arm and a leg. So test environments are easier to set up. You can set up a production system test environment quite easily, because it's a test environment. So you have constrained an environment in one way or another. So that means I've constrained my variables so that I'm able to come up with a test environment. And so that's one thing that we can consider. Test environment are easier to set up because we are in one way or another constraining the variables. So when you're in a test environment, it can be easier to set up your API keys, your databases, cloud, and so on, monitoring, versioning. Okay. It will be easier to do that. What about a production environment where things change, things tend to happen out of nowhere, unplanned events or activities might occur, and your models or your entire system should be robust enough to actually meet those unchanging needs. So in production, coming up with robust APIs is important. It's a hard task that you also need to be concerned with during your testing environment. How do we set up your databases to move data from one point to another? Okay, so because in the backend you're moving data from a different system to a different database to another. So, for example, I'm currently building up a retail model that can be used to predict waste reduction and for a retail case. And so, we have databases. So, how are we connecting these different databases? We have an S3 database. That one is storing our raw information. Okay, telemetry data, point of sale data, and so on. So that's our S3 bucket, storing that type of data, raw incoming data. Then we did set up another database in BigQuery, for when after the ETL process, we have a different database that is storing that information. So how do you link up these two databases? How do they talk to each other, for that matter? Okay, so that is also something that we need to consider when building these models, so that you're not bogged down and you only stay in a test environment. Cloud. So are you going to deploy this on premise, or are you going to deploy those models on cloud? That's also another factor you need to consider. Cloud, I'll say compute is one of the major concerns. So compute, then add on that now the cost. So you don't need to wake up in the morning and realize you have a $10,000 bill on, let's say, Google GCP or AWS and so on. So compute, cloud, you need to also consider that. So what services can we leverage so that cloud the cloud systems, deploying these models on cloud, we can leverage that power, and also what systems can we deploy those in-house so that we can actually minimize on cost, compute, and so on. So you also need to consider that when building these systems. Again, I'll stress on this: monitoring, evaluation, model governance. Again, this is not like a software problem. For a software problem, it can be easier. You can set up your system and deploy it, and even go take a holiday in Maldives or somewhere else. No, but for an ML systems, you have to be constantly monitoring, because the environment changes, and that's a constant. Okay, so if your systems cannot notice this, then you are going to have problems. And so monitoring, versioning those models, how are you going to retain those models if the environment, if there are slight changes in environment and so on. So those are some of the things that you need to consider when you are building these systems, moving from a test environment to a production environment, so that you're able to minimize that time. And so that's where I think the machine learning operations, the MLOps, comes in to actually help you move from a test environment to a production environment, because I think MLOps engineers will have that expertise, and will understand the requirements, what we need, and so on. So whenever you're building these systems, you need to have them in mind. You need to plan for that from the get-go, from when we have decided we are going to build ML systems and how we are going to move those systems to say into production. So just for a parting shot under this is that I deployed, and with this one I'll stress on this, is that a deployed average model creates more value than an excellent model sitting in a notebook. Like that. Okay. So I think these are the of course there are many other reasons as to why ML models do not get to production, but I think these are one, I say these are amongst the topmost reason as to why ML systems do not get into your ML systems have not been getting to production. And so today I just wanted to take a small detour from the tutorials and try to explain the abstract components or abstract things, the other things that tend to surround ML systems or AI systems in a given setting. So today we just brushed on one thing about why ML systems, ML project or data science projects never get to production. And so I'll keep on finding good topics that we can also do a discussion. And in the subsequent ones, I'll maybe try to invite you so that we can have a discussion about data science and various other topics that we can counter. So once again, thank you for your time. Subscribe to the channel if you haven't. Then if you have any concern, any topics that you think we can discuss, please get to the comment section, and we can plan for that. Okay. So once again, thank you, and until next time, see you.